So we're going to start with trigonometry, and we've broken this up into 3 parts. The first part is called Part A, finding ratios. So our goal is just to be finding fractions. When we do trig, what we're going to be doing is setting up certain fractions. And the key to this is knowing what fractions we need. So sine of theta, that's a Greek symbol, and it's standing for an angle, is equal to opposite over hypotenuse. I've abbreviated it, opposite, OPP, over HYP. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So to try to figure out which piece these are, first thing you got to know is we kind of call this SOHCAHTOA. Just to abbreviate it so that we remember which ratio goes with which. So for sine, we use O over H. That's where that SO is coming from. Ka is cosine, adjacent over hypotenuse, and TOA, tan, opposite over adjacent. When we're labeling our triangle, this is part of the biggest thing that you can do throughout all of trig, is wherever that missing angle is given by that Greek letter theta, we label right across from it the opposite. And across from the 90-degree angle, we call that, and I'm sure you've done it before, calling it the hypotenuse. And trig is only useful for right triangles. So it has to be a right triangle with the hypotenuse as the longest side. If you look up at the top, you'll see that there's also one more side we call the adjacent. And that's honestly, we call it the adjacent because it's kind of our leftover side. Adjacent means next to. If we're looking at this triangle, you might think, oh, the bottom of the triangle is always the adjacent. And that's not true. If you look over to the right, wherever theta is across from that missing angle, that's the opposite side. Across from the 90-degree angle is always the hypotenuse. And that leftover side is always the adjacent. So when we're trying to set up these ratios, you're basically trying to come up with the fraction. We always need to know which side is which. So across from that missing angle, label the side with the 16 as opposite. Across from the 90-degree angle is the hypotenuse. So label the side with 20 as the hypotenuse. And that leaves that bottom to be the adjacent. Now, when we're trying to figure out these ratios, we're basically just looking for a fraction. So for sine, if you look above, we're looking for the opposite over hypotenuse, which you might want to just abbreviate O and H. If you look the opposite, we labeled that side as 16, and we labeled the hypotenuse as 20. Cosine, if you look up top, we're looking for the adjacent over the hypotenuse. Looking at the picture, the adjacent is 12, the hypotenuse is 20. And the tangent, we're looking for the opposite over adjacent. From this picture, the opposite we labeled as 16, and the adjacent we labeled as 12. Now, I think all these can reduce. Technically, these are all perfect. But if this were a question on a quiz, I probably wouldn't put 16 over 20. I would probably put 4/5 because it can reduce to 4/5. I wouldn't change it to a decimal just because we're talking about a ratio, which it makes sense to kind of leave it as a fraction. 12 over 20, I think, reduces to 3/5. And 16 over 12, I believe, reduces to 4/3. So for number 2, because that angle that's missing we call it theta, that Greek letter, is across from 3. We call that side the opposite. Across from the 90-degree angle, we call it the hypotenuse. And the leftover side, we call adjacent. Setting up the ratios, if you look up at top, it's opposite over hypotenuse. So 3 over 5. Cosine is adjacent over hypotenuse, or 4 over 5. And tangent is opposite over adjacent, 3 over 4. And I would leave them as fractions. For number 3, you'll notice these are turned, flipped triangles. You're looking for the missing angle or the angle that's designated. Across from it, we call it the opposite. Always take a minute and just set these up. Across from the 90-degree angle is the hypotenuse. And that leftover side is the adjacent. So we never really start with the adjacent. We just pick what's left over. Adjacent means next to. Sine of theta is supposed to be opposite over hypotenuse. 24 over 25. Cosine is supposed to be adjacent over hypotenuse, or 7 over 25. And tan is supposed to be opposite over adjacent. Opposite we have marked with a 24, and adjacent we have marked with a 7. And I think those are all reduced. We just leave them. So there's other levels, other stages, but we're just going to leave them for right now. And last but not least, look where that missing angle or that theta is across from it, opposite. Across from the 90-degree angle, hypotenuse, leftover side, adjacent. Sine would be opposite over hypotenuse, so 15 or 5 over 13. Cosine is adjacent over hypotenuse, so 12 over 13. And tangent would be opposite over adjacent, so 5 over 12. That's how we set it up. Take a minute and begin the next part in this packet by going through and labeling across the arrow, across from the missing angle, and labeling it opposite, so you get that idea each time that across from that missing theta is the opposite. Across from that is the opposite. Across from the 90, hypotenuse. 90, hypotenuse. Go through the next page and try to label and solve.